Okay, so I just finished doing number 46 on page 400, and it's really important that I keep going because there's another way of asking almost exactly the same problem, and it looks very different. It seems like it's going to be a totally different problem, so I want to show you that too. Look at page 385. It says, in problems 83 to 92, a point on the terminal side of an angle theta is given. Find the exact values of the 6 trigonometric functions of theta. And by the way, I didn't mention it. These are pages in your trig book that are specifically on your review. So make sure to look at these pages. Okay, so again, it says that this is a point on the terminal side of my angle, and I'm supposed to find all 6 trig functions. So let's look at number 84. Okay, number 84, it says the point 5, -12 is on the terminal side of my angle. Well, remember on these pictures here, the terminal side was this one right here. That's the terminal side, the hypotenuse. Okay, so by saying that that point is on the terminal side, they're basically saying that they're giving you this point. This point at the end of your little segment coming out from the origin. So I'm going to draw a very similar picture, or pretty much the same. I'm still going to start at the origin, but instead of knowing which quadrant I'm in, because I'm told, hey, it's quadrant 3, or hey, it's quadrant 4, the way I'm told which quadrant I'm in is I'm given a point. And in this one, I'm given 5, -12. Well, 5, -12 means 5 to the right and 12 down. That's how I know which point. You don't have to draw it in exactly the right place. You just have to draw it in the right quadrant. 5, -12 is right here. So I'm going to draw that terminal side from the origin to that point. Now I have to complete my triangle. From here on out, it's just like the other problems. I always go back to the x-axis. Don't ever draw your triangle to the y-axis. It's actually a little bit easier. Well, no, it's really pretty much exactly the same. Okay, this point, remember, says that from the origin, I'm going 5 to the right and 12 down. So that means this right here is 5. If I'm going right 5, and this right here is a -12 because I went down 12 to get here. Excuse me. So instead of in these problems, the ratio here gives me 2 sides of the triangle. This problem, it's the coordinates that gives me 2 sides of my triangle. It's pretty much the same thing though. I would use Pythagorean theorem again. Leg squared plus leg squared is hypotenuse squared. So that's 5 squared plus -12 squared equals, we don't know what squared. 25 plus 144 is x squared, and that happens to be 169, which is 13 squared. So here's 13. Remember the 13, the hypotenuse, you don't ever have to worry about negatives. The hypotenuse will never be negative. So now I'm doing exactly what I did before. Here's my theta. Here's my adjacent. Here's my opposite. Here's my hypotenuse. Sine is opposite over hypotenuse. And that goes with cosecant. Cosine is adjacent over hypotenuse. That goes with secant. Remember, these are called reciprocal identities because one is the reciprocal of the other. Tangent, opposite over adjacent. That goes with cotangent. And I'm done. If I'm asked to find the cosecant, I just get it right here. If I'm asked to find the tangent, here it is, and so on. Okay? Remember, the way I like to remember which ones go together is first cotangent and tangent totally go together. Okay? Those two are reciprocals. Then, in terms of which ones here go together, is it crisscross, whatever, remember that each of them, each pair, has one that has a co. This is the cosecant. This doesn't have a co. They go together. This is a cosine. This doesn't have a co. They go together. You could also think of it as a pair of S and C. S and C go together. S and C go together. Just don't start thinking this. The sine is one of the primary ones and the cosine is one of the primary ones. Okay, let's do one more like that. Let's look at number 86 on the same page. This was page 385, number 84. Okay, I'm going to do page 385, number 86 next. This would be a really good time for you to pause this video and try number 86 on your own. Number 86 says, and again it says the terminal side of an angle is given. And that's what the directions would be like on your midterm if you have one like this, which I'm pretty sure you will. Okay, so the terminal side is given, excuse me, a point on the terminal side is given. Okay, so they're saying this is a point on the hypotenuse of my right triangle. Find the exact values of the 6 trigonometric functions of theta. Remember, exact values means keep it in radical form. Don't change it to a decimal. You don't really have to worry about that on a multiple choice test though, because it is what it is in terms of what form it's in. So this point is -1, -2. So that's the point that I'm being told is on the terminal side of the angle, -1, -2. Pause it here if you want to try it yourself. Okay, I start by drawing my x and y axes. And then I think about where -1 is and -2. So I'm going to the left and down. And again, I don't really have to be accurate with where it is. I just have to put it in the right quadrant. I moved it out a little further than I needed to just so I have more room for my triangle. Now go from the origin to the point for the terminal side. And there's my triangle. Remember, it has to go back to the x-axis. There's my right triangle. And this is telling me, -1, -2 is telling me I went -1 to the left and down 2, which is the -2. So Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared. I don't know the hypotenuse in this case. So this is 1 plus 4 equals x squared. X squared is 5. So finally we have one that has a radical. Hallelujah. Something a little more interesting. Okay, now we're going to find all of our functions values. Sine, cosine, tangent, etc., etc., etc. Okay, so sine, first of all, let's figure out this is where theta is. This is my hypotenuse. Okay, remember the angle is always between hypotenuse and adjacent, so this is adjacent, and this is opposite. So sine, opposite over hypotenuse. Okay, this cannot be left that way, can it? I'm going to come back though. Let me show you why. Let's leave it that way very temporarily. Adjacent over hypotenuse for cosine. Opposite over adjacent for tangent. That's -2 over -1, which is just 2 over 1, or 2. Now here's why I didn't simplify this. I didn't go ahead and rationalize my denominator. It's because I'm about to flip it anyway. Let's go ahead and flip it, because when I flip it, that doesn't have a radical in it. Okay? Secant. When I flip it, I'm good. If I had changed it first and then flipped it, I would have to rationalize again over here. Now I still do have to rationalize these. It's just that if I had rationalized them first and then flipped them, then I'd have to rationalize again here. Okay, so now let me rationalize these. Multiply by square root of 5 over square root of 5. I did not leave myself much room, I'm sorry. And this is what I get, because on the bottom is 5. Square root of 5 times square root of 5 is just 5. On the top, -2 times square root of 5. Same thing here. On the top, -1 times square root of 5, and on the bottom is just 5. So here are my answers. Make sure you understand which ones are the answers for the sine and the cosine. I do have to rationalize those denominators. I just wanted to go ahead and figure out the reciprocals before I did so.